Good evening, everyone. I'm Miss Johanna, and I'm going to discuss about esterification of carboxylic acid and alcohol. As we know that ester is the product of esterification, and esterification is the reaction between carboxylic acid and alcohol. So here, what I'm going to draw is the carboxylic group and alcohol group. Okay. I'll just draw it like this. So let's say we have an alcohol with one member of carbon and then a carboxylic member of two carbons. So I'll just put it here like this. And then here, I'll draw like this. So this one, the name is ethanoic acid. And alcohol name is methanol or methanol or just methanol. Okay, so when we add them in a reaction that is catalyzed by sulfuric acid, so sulfuric acid is the catalyst here. So what happened is that the hydroxy or OH of the alcohol will leave the ester or the new product formed, yeah. So then there will be a joint bond, and then it will produce a joint bond like this. Okay, so here, this is the rest of the carboxyl. Okay, in this case, it doesn't have the H anymore, but it is replaced by the part of the alcohol. So this is the ester that is produced, but don't forget we have to add water, so plus water. Now, what's the name of this ester? Okay, the name of this ester is the rest of the alcohol part we call by alkyl, okay, and then the rest of the carboxylic part we call by carboxylate. So in this case, because the member of the alcohol is only one C, it means that methyl, and then the rest of the carboxylate, yeah, has only two C's, so we call methyl ethanoate. All right, yeah. So now, guys, let's take a look one thing that is also actually interesting. So methyl ethanoate, if we see the molecular formula of methyl ethanoate, we have C3, okay, and then H6, C3, H6, and O2. All right. Now, what makes them interesting is that this is interesting because when I draw another part of another member of carboxylic acid, let's say I am drawing a member of carboxylic acid with 3 C's, yeah, so like this. And the name of this member is propanoic acid. All right. And then if we calculate, it has the molecular formula C3H6 and O2. If you see over here, their molecular formulas are the same, but then one is the member of carboxylic acid, and then the other is the member of esters. So this is what we call, this phenomena is what we call, okay, functional group for isomer, functional group isomer. So functional group isomer is included to one of the varieties of the structure isomer. So for your information, structure isomer has chain isomer, position isomer, and functional group isomer. So right now what we are learning is the structural isomers that is included to the functional group isomers. So in other words, we can say carboxylic acid with the same number of C will have the functional group isomers with ester, of course, with the same number of C's. Okay. I think that's all first for today. Thank you so much and keep on learning.